So if there is pressure, I asked Sammy to do this, the particles are still moving. So how do we get them to a pressure of 0? Where would pressure be 0 on this? Way in the negative of temperature, which would be this way, right? What if we just go like that? At this location, wouldn't pressure equal 0? So all we do is we shift this y-axis over. Let me eyeball that. Oh, that's not a straight line. Pressure. So what temperature is this? Right there. Definitely negative. Okay? So we got to figure out what is the temperature at pressure of 0. So that's what we're going to do right now. And again, you don't have to write this down. Just try to follow along. So at what temperature does pressure equal 0? And in order to do that, we're going to use the equation of a line that I know most of you have seen before. What is that equation? You sound so excited. Sorry. Love this stuff. Okay, what is that? Slope. Again, you are not going to have to do this. This is just so you can understand why we don't use Celsius when we deal with gas laws. What is B?
Y-intercept.
It's the y-intercept. Okay, well, let's start by finding our slope. Oh, I have a couple of points that are from a certain group's data. It would be great to see if you could try this on some of yours to see if you end up with a better number than I end up with in the end. This point is 29.6 and 104.3, and this is 40.8 and 107.7. So slope. Remember, slope is rise over run. So 107.7 minus 104.3 kilopascals over 40.8 minus 29.6 degrees Celsius. And if I do that math, it gives me 0.3036 kilopascals over degrees Celsius. Okay, there's my slope. Great. Now let's find the y-intercept. So B, I will just rearrange this equation to solve for B, is y minus mx. And so y, I will use this set of values, 107.7 kilopascals, minus, here's my slope, and then x is this guy right here. So B would equal 95.31 kilopascals. Wait, sorry, hold on a second. Oh, that was right. Those cancel out. Again, I'm not going to ask you to do this on a test. It's just so that you can understand why this is not proportional. We can do better. All right, so now I have my y-intercept. Now we have the information we need in order to find the temperature that pressure would actually equal 0. So if pressure is 0, then we'll set y equal to 0 because pressure is on the y-axis, okay? So we'll take our y equals mx plus b, 0 kilopascals equals my slope of 0.3036 kPa, degrees Celsius, times x, that's what we're solving for, what's the temperature, plus b, that's my y-intercept right here, 95.31 kilopascals. Solve all that for x, and we'll go through all that. X equals, now this is this data from a particular class, negative 313.9 degrees Celsius. That's really cold. We could not achieve that in this classroom. This is really close to an accepted value of absolute zero. Does anyone actually know what the real value is in Celsius? Lucas would, but he's not with us right now. Okay, so over here, let's start writing down a couple things for our P versus T.
What page is this?
I have it on page 62.
Oh.
When we're using Celsius, pressure is not proportional to temperature. In other words, if we went from 50 degrees Celsius to 100 degrees Celsius, we would not double the pressure. It would increase, but it wouldn't double because it's not proportional, okay? However, if we use a different scale, notice that we could bring it back to this temperature that is actually, it's not negative 313, it's negative 273 degrees Celsius. So we were pretty close. That's not bad for high school lab data. Negative 273 degrees Celsius is what we call absolute zero in Celsius, okay? That's a really weird number to use. Let me just finish this one thought, Ryan.
Yeah, no problem.
So instead, a new scale was established called Kelvin. Have you heard that before? A couple of you? Okay. So when using the Kelvin scale, pressure is proportional to temperature. So if you double the temperature, then you double the pressure. Question?
Yeah. What's the transition rate between like Celsius and Fahrenheit?
Oh, it's a complicated, like 5/9 times something plus 38 something. I never remember. I have to look it up.
Oh wow, that's lots.
Something that no one should have to memorize ever. Okay. So if we use the Kelvin scale, then they are proportional. So here's how you get. It's an easy conversion. So convert from Celsius to Kelvin by adding 273. We got negative 273 is our absolute zero. So if we add 273, what are we at? Zero. Okay. So instead of saying 273 Celsius, we would say 0 Kelvin. Okay. So for example, if you have 20 degrees Celsius, add 273 to it, and you get 293 Kelvin. There's no degree symbol, it's just K. So we have one more law here, and this is, I can finally erase this graph. One second. Yes?
Do any countries use Kelvin instead of Celsius?
Ooh, not that I'm aware of. I think most instruments are designed like for temperature, for Kelvin, for Celsius and
Who
Fahrenheit.
uses Kelvin?
Scientists.
Who uses Kelvin?
Scientists.
Okay.
So this is what we call Gay-Lussac's law, almost done, where because pressure and temperature are proportional, this looks like another law that we did before. Which law?
Avogadro.
Avogadro's, right? So if we were solving for P2, that's our law.